Alright, so in this lesson we're going to be looking at what a limit is and how it functions and how we can solve for a limit. So by looking at this graph, if I were to ask you what the limit of 3 is, that could be a little confusing at first. So let's take a look at what a limit actually is. So a limit is just a way of asking where's the graph going at a certain point. There's a couple of rules that need to be stated about a limit first, and those rules are stated plainly. A little theorem word box saying the limit as x approaches a of f of x exists if and only if the limit of x of a from the left of f of x is equal to the limit of x of a from the right of f of x. This means that when looking at this graph, when you're coming from the left and from the right of the graph, you should be able to sit there and get the same value, and that's the limit of the graph. So let's look at an example right here. If you're told to find the limit as x approaches, let's go with -2 of f of x. What would you do? So what you simply do is you follow the graph from both the left side and the right side, from -infinity and +infinity, and you go to -2, and you get there, you see it's a +1, and because they're both +1, the derivative then equals +1. So what does it mean? Or actually, no, let's try another one real quick. The limit as x approaches 8. So again, you'll go from the left of the graph and the right of the graph. You're going to go to point 8, which is right here. It's both the same, and that is 3 this time. So x is going to equal 3. Box this one. So there's those two solutions with the limit. So here's another question. What's it mean if the limits from the left and from the right don't equal each other? So if we say what's the limit as x approaches 3? So here you're going to follow your graph. You're going to go from the left of the graph over to 3, and you see that equals -infinity. So the limit as x approaches 3 from the left, right here, is equal to -infinity because it's continually going down. But the limit as x approaches 3 from the right, so from this direction, is +infinity. Well, that's a problem. These two values are not the same. One's a -infinity, one's a +infinity. So this means that in this instance, the limit as x approaches 3 does not exist because the values as x approaches 3 from the right and x from the left are two different values. Another interesting fact to do with limits. No, please don't. Cat. Can't be here. Let's see. Another. You'll cut this out, please. And let's take a look at some more graphs, actually. Let's take a look at this graph. So, this graph up here. Alright, this graph right here. So, the graph here is asking if you're going to -infinity, what is going to be the limit of this graph? So you start with it and you're going towards the left, that's -infinity. As you go there, you'll notice that you get to this horizontal asymptote at positive 2. This means that your limit as you go to negative infinity is going to be positive 2, because the graph cannot go past this horizontal asymptote, and when you go from left and from right, both are stopping as when they get close enough to x equals or y equals 2. The second one is asking as the list limit as x approaches infinity. So this time we're going to the right, we're going this way. And you're watching as it goes down, which means it's going to be negative infinity, because the graph going to the right, from the left and from the right, are both going in a downward direction, which will mean that the limit is negative infinity, because we don't know where it's actually ending, because it's continuing on. And that's why we get negative infinity. So that's all on limits for now. If there's not anything else I can help you with, please check out my other videos and I hope that they've been a help to you.